Hi everyone, and welcome to Chapter 6, Broadband Solutions. This chapter is pretty short with just one lab, and don't worry that it's a little light. There is a little bit of legacy stuff discussed here, but mostly we're going to deal with DSL in our lab. But this is brief, and we'll get you going and caught up on how teleworkers use DSL to communicate on point-to-point over Ethernet connections. So, to start, the introduction to teleworking. This really doesn't take a lot of introduction. In the last few years, people have started teleworking all over the place. We probably all know someone, and especially in this class where if you consider this class and study to be work, which I do, then we are all teleworkers. The difference is the way we may connect with where we're going, and oftentimes anymore, so that the security that is provided with inside a network can pass out to a user, we use VPNs, virtual private networks. There's also VoIP and video conferencing ways that we can network together and get our work done in a company. And so what does a teleworker need? Well, you need a good internet connection, and generally that happens either over cable or DSL to the home. Satellite may be in the bush. It's a little bit tougher to do, but it can happen. But that's the general requirement. And then with the VPN, the VPN allows for this center here in the tunnel to be encrypted, so it can leave the remote site and travel encrypted to the VPN router, which can decrypt and pass into the network. So, cable system, standard cable system that's in the urban parts of Alaska and any other city, tends to be distributed throughout the town. And the problem with cable, went back in the day in the 90s when we first brought it into our neighborhoods, was that it attenuated. So every neighborhood that had it, as more neighbors brought in cable modems, then the bandwidth would deteriorate until they ran another last mile. So they would have a trunk, an amplifier, and way out by the house would be, the last mile distribution feeder at the head end, and it would, or out in the neighborhoods, they would run fiber to a neighborhood and then cable throughout. And it got pretty weak after a while. But that was minor detail, and eventually the cable industry caught up. So as a user, you wouldn't notice any difference between cable and DSL. It's really just a matter of who your providers are and what access you have. Now, a couple of cable components, the DOCSIS, the data over cable service spec, and this is just a little bit of detail on how that works. The communications support over cable is on layers 1 and 2, all right, which is pretty much everything point to point. And the cable components, you need a cable modem terminator at the head end and the cable operator, and then in the other end, you need what's called and then the cable modem on the subscriber side. So you have a little box, you have a cable modem in your house. If you have cable, you probably have a modem that looks like a switch, because there's probably 4 Ethernet ports. I know I get my cable from the internet, and it looks just like a Wi-Fi box anymore. And that little router handles switching and wireless throughout the house for me, all in one device. I don't need separate ones any longer. Now DSL, the interesting part about DSL is it's just plain phone wire, so the infrastructure is already in place. There's a lot of cable subscribers, but there were a lot more phone landline subscribers. So, of course, interestingly now, we're cutting the cord on landlines, at least I have anyway. So I wouldn't be interested in DSL because I bring in cable, but I'm cutting the cable cord and I'm cutting the landline, so we'll probably all end up with some kind of different access down the road. But there's two types of DSL, asymmetric and symmetric, and It uses a frequency range that's outside of the telephone calls for years and years. You know, they always ran 4 wires in the telephone system. They never used all of the technology till about the 90s when they started using DSL at all. And now they can get, you know, with symmetric DSL, you get up capacity, you know, several, you know, well, I don't know about gigabit, but several bits of data back and forth. All right, and it carries up to 3 1/3 miles for ADSL. So that's not bad compared to cable. And for a DSL connection, you have these in your home. You have a transceiver, which connects to the computer. It's in the, you know, you have it looks like a phone connector, but it connects both your telephone for one set of wires and DSL for the other side. And then, of course, on the carrier's office, there's what's called a DSLAM, the DSL access multiplier, and it takes all of the individual DSL connections from users, puts them into one high link on the ISP. So at the, you know, using asynchronous or synchronous DSL, the customer and central office, there's a demarcation point where, you know, analog phone comes in and the PC data comes in, and they can travel together on the POTS, the plain old telephone system, and the asynchronous DSL. And then on the inside of the CO in the central office, there's a POTS splitter, and that separates the analog voice from the digital data into the DSLAM. So that's the basics of how your DSL works when you're away. So what about broadband wireless technology types? How do we set up point-to-point? In the chapter, and I'll highlight it right here, in the chapter in your book, sorry, time I click, I jump. There's, I've got a couple articles on WiMAX, because WiMAX is how towns in Alaska got their access for a long time, and a couple years ago it was shut down. And one of them has a newsletter, you know, Stop the Cap. It connects to that. Go ahead and browse on that. Click on the title and browse the current editions of the news articles as well. So WiMAX says it can provide all this, but in Alaska it sure can't. And it had, you know, 2 megabit max, so it really didn't, you know, it really wouldn't fit with today's technology needs, and that's why it's shut down. But it was cheap, $20 a month versus a lot more now. So there's cellular, 3G, 4G. I'm not sure what you use. I'd be curious to have a little survey of what you guys use in your areas, especially in the villages. Satellite implementations can be very, very tough indeed. We have a couple of students out there, so go ahead in your assignments, submit and let me know what they are. So here's just a little page of comparisons. This is in the chapter too, so I'm not going to read through it right now. But this is all the different ways that people can get to your home. Like I say, WiMAX doesn't really work anymore. Some municipalities have Wi-Fi, some do not. Some need satellite, some can avoid it. If you've got fiber to your house, good for you. That's quite expensive. So DSL and cable are still pretty much the general solutions. Now, what we're going to be doing in this chapter is configuring XDSL, a type of DSL. So there's just one lab, but it's pretty informative. Normally you would just configure your own side of it and the telco configures theirs, but in this case we're going to do it both ways. And it gets a little bit complex, which is why I'm showing you this next slide. Or I should say the slide after. This is how we create the PPP tunnel. And we're going to create an interface dialer, which is like a virtual dialer on the router, so that contacting the home, there's a dialer that's encapsulated in PPP, all right? And then it's also authenticated because, you know, you want to, well, the telco wants authentication for a couple of reasons. One, they want to know it's you, but mostly, you know, if you're not paying your bills, they want to go in and be able to change the authentication and shut it down. But, so anyway, we have a dialer name, And then the MTU, maximum transmission unit, that's how they provision how much is coming through. And then the dialer pool is the name of a dialer. So we're calling it dialer pool 1. And we've named dialer pool 1 PPPoE client dialer pool number. Very convoluted. But you're going to see that in the lab that we'll be doing. Step by step, you can go through the lab. You're going to see a couple of terms. I'll give you this one now. BBA is Broadcast Access Aggregator. I had to look that one up. I forgot what it was. So there we are, configuring DSL. I'll stop the show. I'm at 10 minutes. That's a hair over my time. I'll see you in class, and good luck with the lab and the test. Thanks.